All right, finally, we want to talk about using lines to model real-world situations, the whole point of what we're doing in mathematics as a general study is to answer questions about the world around us, right? We can look for patterns, we can make predictions. That's what we mean when we say modeling. Using a linear model, we can make a graph, right? Either by hand or via technology. So if we have points, we can plot those points and then find the line between them. We can then use that graph to make predictions. Now, when we make predictions, when we make estimates about values that lie between the points on our line, so if we have a couple of data points, we plot those things, and then we make predictions about the points falling in between our data points. We call that interpolation. It happens inside of our data set. It is interpolation. If we make estimates or predictions beyond our data points, that's called extrapolation. It's exterior to our data set. It's extrapolation. We extrapolate. So let's consider the following situation. The cost of Tam's cell phone was $410 after 5 months of service and $690 after 9. So 9 months of service cost $690 total. We can create a model using these 2 points. So I graphed these 2 points. I used Desmos and then connected them with this line. I can use this graph then to answer some questions. So here's what I want to answer. Just by looking at the graph, let's try to estimate Tam's cell phone costs at 8 months. Look at our graph here. Let's find 8 months. Here I have 10, 9, here's 8. 8 months. I'll just come up here to the graph and have a little looky-loo. What does that appear to be? It appears to be approximately 600. So I would guess that Tam's phone costs after 8 months were somewhere around $600. I'm going to answer the question. I'd say probably around $600. Would that be an example of interpolation or extrapolation? Well, looking back, our known data points are here at 9 and here at 5. Well, 8 falls in between. 8 months is in between those two things, so in between is interpolation. So $600 and it's interpolation. Happens in between. Let's look again by inspection. What do we suppose Tam's costs are at 12 months? Looking, we'll start here. Here's 10, 11, 12. Up to the graph. That's our point there. It appears to be around 900. We would estimate that to be $900. Of course, I'm going to ask, is this interpolation or extrapolation? Well, let's look. Our known data points are here. So 5 and 9. 12 is outside of that. It's outside of our known data set. That's going to have to be extrapolation. So what did we say? We said this was about 600 and it was interpolation. That appears to be something around 900 and it's extrapolation. Let's go ahead and find a linear function modeling Tam's cell phone costs, given what we know. What do we know? Let's see. Well, according to the previous page, we know if I let t be months, that when t was 5 months in, Tam's phone cost them $410 total. I also know that at t equals 9 months, it was $690 total. So I have 2 points on a line. I could find the slope between those two. I will let the 9 months be my second point and the 5 months be my first point. So y2 minus y1 divided by x2 minus x1. I've said let this be 0.2 and let this be 0.1. So filling in, I would have 690 minus 410 divided by 9 minus 5. See, 690 minus 410, well, 6 minus 4 is 2, and 9 minus 1 is 8. 280, and 9 minus 5 is 4. 80 divided by 4 is 20, and then 2 divided by 4, 50. Adding those two, I get 56. It's 70. So it tells me my slope, and write that over here. My slope must be 70. That's the first thing we need. Next thing we need is the intercept. All right, to grab a hold of the y-intercept, since we're using a linear function, that means slope-intercept form. Might as well just use my old friend, y equals mx plus b. We know m now, and we have 2 points on this line. I'll just use the first one. Smaller numbers, usually easier arithmetic. M, 70, and the x here is a 5. B, so just inputting the point here. 70 times 5, 350. Last thing I need to do, just solve for b, so I'll subtract that old 350 from both sides. 410 minus 350, 60. Tells me b is 60. Putting those things together, I should call my function something. I think I will just call it P of t. That'll stand for phone bill at time t. What is the slope? The slope is 70. Now my independent variable, I've changed it from an x to a t, so I'll write t, call it t, plus the intercept, 60. Next we ask, how much is Tam's monthly bill? What is the monthly bill really? Monthly bill, that's a rate. You're charged a certain rate each month. What is the rate on this function? Well, rate means slope. There's our slope right there. What are we charged each month? Our slope says it is $70 per month. Next, we ask, how much was Tam's activation fee? How do we interpret activation fee? Well, we haven't even had the phone plan a month yet. You walk in, you say, hey, I'd like a phone plan. And they say, sure, it'll be $70 a month. Also, we're charging you $60 just to activate the phone plan. What does that mean? That means T is 0. What is that? That's the intercept. What was the intercept? 60. So before we've even had the phone plan for a month, we have been charged $60. That's our activation fee. That's our intercept. That's going to be it for us for chapter 2. Up next, we started on chapter 3. Chapter 3 is all about solving systems of linear equations. So we started with a single linear equation. Next up, we're going to up the difficulty and throw in a second linear equation and learn how to manipulate those things simultaneously.